Good morning, Miss, and to my fellow friends. I'm Loi Zhao Yang from Group 3, and all my group members' names are Li Wei-shon, Nicholas Wong Ding Shen, and Muhammad Nasmin bin Kamaruddin. So, this is our program execution expression, which we design our own program expression. All this we will talk about it later. First, we will talk about postfix notation. So this is our equation expression. So first, we'll do all the equation inside of the bracket and multiply and divide. So this sy into this and ge multiply into this and hq divide to this, and inside the bracket b minus k into this and l multiply r into this. Then we'll move the divide into the back, divide to the back, and the minus to the back, and the minus to the back, and the multiply to the back to here, and the plus into the back too. So now we are going to combine these two to this, and then we are going to combine these two to these two to this. Then this will remain at here first. So we will move this plus to the back. And then finally we're going to remove all the bracket, and this minus will move to the back. And that's all for the postfix notation. So now we'll talk about stack diagram. Here is our own design program execution expression. So here is the format instruction. So now we'll talk about it. First, push S, so we'll add a S here. And then push Y, we'll just add a Y here. And then addition, we just add S and Y. And then push D, then we will just add a D here. And then division, we'll just get this S plus Y to divide by D to get this. And then push G, then we just add a G here. And then push E, then we just add another E here. And then multiply. Then we'll take this G and to multiply E to get this. And then push C, we just add a C here. And subtraction. And we'll get this to minus C to get this. And then multiply. We'll get this to multiply this, and then to get this. And then push H, then we will just add a H here. And then push Q, then we'll just add a Q here. And then division, then we will take this H to divide by Q to get this. And then push J, we just add a J here. And then subtraction, we get H divided by Q to minus J to get this. And then we're going to push A, then we just add the A here. And then push B, we add a B here. Then push K, Same thing, we are going to add another k here, and then subtraction. We'll get this b to minus this k to get this, and then multiply. We'll take this a to multiply this to get this, then division. We get this to divide by this to get this. And then we just add it. We'll take this 2 to add to this. And then pop z, we just add in front z equal, and that's the final answer. And that's all for this stack diagram. So now I'm going to talk about the zero address machine instruction. So this is our own question, our own design program execution expression. So as the usual, we'll just do the inside of the bracket and multiply and divide. So s plus y to sy, and this l multiply r, l multiply, and this h divided by q into this, and then b minus k inside the bracket into this, and g multiplied by e into this. And now we will just move the divide into the back, and the plus additional to the back, and the minus to the back 2, and then the multiply to the back 2, and the minus to the back 2. And then we'll just combine again. We combine these two into this, and we'll combine these two into this, and this will just remain here. And then we will just move the other bracket away, and this move this minus into the back, and that's all. And this s, the first one is s, so push s, then y, push y, and then additional to here, and d, push d, and divide, division, and push l, this l, push l, and r, push r, and then multiply, and then push x, and then addition, and then multiply, and then push h, and push q, and then divide, and then j, push j, and then minus subtraction, and then a, so we're gonna push a, b, push b, k, push k, and then minus to subtraction, then multiplication, and then divide, and then additional, and then push g, then push e, and multiply, and push c, and then minus subtraction, another minus, so another subtraction, and lastly pop z. And that's all for the zero address.
Hi, my name is Muhammad Nazmi bin Kamaruddin, and today I'm going to discuss about how to do a 3 address machine instruction. So, x equals to a plus b multiply c divide d minus e multiply f minus g plus h multiply I. This is equation that we need to do. So the first thing we need to do is this table. So the first table, what we need to insert inside them. So the first thing, okay, we always do at the back, g plus h multiply I. So we do the bracket first, h multiply with I. So multiply, we type multiply, and R1 is, we can do any register. I'm going to register under R1. So R1 and H multiply with I. So HI. So here inside this table we put H multiply with I, and below is R1. So we register under R1. So the next is G. So we add, plus we put add. So add, we are going to register under R1 too. So G and R1. So because why R1 is because this is we already registered under R1. So add R1 G R1. So G plus H multiply I. So this one. So register under R1 again. So next step is we are going to do this bracket D minus E multiply F. So the first thing we need to do is be inside bracket. So multiply, we use new register which is R2. So multiply R2 and E and F. So we put like this, and then E multiply F, we register under R2. And then next is this subtract. Subtract is like minus. So subtract, we use same register R2, and then we put D, which is here this one, and then we put R2. Why we put R2 is because E minus F we already register under R2, so we put R2. So D minus D subtract E multiply F, we register under R2 again. So this one, next step is multiply this one, this bracket. Okay, so multiply R3, we register under R3, new register. Okay, so multiply, we put multiply and register under R3. So new register, and we put B and C. This one, B and C. We do inside bracket first. So B multiply C. So we put B multiply C, register under R3. Add R3. So because this is add, so we put R3, same register, and put A, and we add A with R3. Before this register is B multiply C. So A plus B multiply C, we register on the same register, which is R3. So and then the final is we subtract Y, which is this one, subtract, and then we put subtract, we put new register which is Y, and then this one we register as R2, and this one we register as R1 like we did before this, and then subtract Y, R1 and R2. So D subtract E multiply F, and G subtract with G plus H multiply I. So we register under Y. And then the final is we divide. So we divide, we put a new register which is X, because here is X. And then we put R3, which is this one, R3. And then we put Y, this one that we already did. So this is the final one, A plus B multiply C, divide D, subtract with E multiply F, subtract with G plus G add H multiply I, and we register under X. So now we are going to do two address machine instruction. Two address machine instruction is more works from three address machine, which is this one, three address machine. So two address machine, this is the equation. Y equals to A subtracts B divide C plus D multiply E divide F plus G multiply H. So the first thing we need to do is we're going to do the same method but different things. So like tree address machine, we can do direct like this, like multiply. We want to H multiply with I, we can do direct multiply H and I. But two address machine, we cannot do straight like that. We want to move first. So if we want to G multiply with H, so the first thing we need to do is move G into R1. This is register R1. So we move G into R1 and then we multiply H and R1. Same register G multiply H R1. And then next is this one. Add F into R1 and F add G multiply H and register under R1. So next is we're going to do this one, which is multiply. So we're going to move first. So move D into R2 into register, new register R2. So D R2, and then we multiply E with R2 and register under same. Then D multiply E and register under R2. And then next we are going to move R3, which is we move this one. We move B into R3, new register. So B R3. And then we divide. We divide C and R3. So B divide C and register under R3, same register. And then we're going to do this one. Y A. We're going to do this. So first thing is move A into Y. And then we subtract. Subtract R3 and register under Y. So A subtracts B divide C and register under Y. And then we add R2, which is we did this one, R2. D multiply E. And then we add Y, which is this one. So E subtracts B divide C, add D multiply E. So we do under register Y. And then the final is we divide Y, we divide R3, which is this one, and Y. So A subtracts B divide C plus D multiply E divide F plus G multiply H and register under Y. So now we are going to do one address machine instruction. One address machine instruction is more greater than two address machine instruction. So this is the equation. X equals to A plus B multiply C divide D subtract E multiply F plus G multiply with H. So the first thing we need to do is we have to load E, and then we can do multiply, load E and register inside accumulator. So the second one is multiply F. So we do E multiply F and load and register under accumulator. Store T is like we register under T. So we put E multiply F and register under T. So the next thing we need to do is we have to load D and put inside accumulator and subtract T, which is D is E multiply F. So D subtract E multiply with F. So this one, we already finished this one. And then we are going to do the new one. And then we store into T. Yeah. And then we're going to do the new one, which is this one, G multiplied with H. First thing we need to do is load G and store into accumulator and multiply H. So G multiply H store into accumulator and add T and add T. So D multiply E, D is this one. D multiply E, D subtracts E multiply F. So this one. D subtracts E multiply F plus G multiply H. So this one, so we store accumulator and now we store into T. So now we load B, which is this one, B, this one, B, load B and multiply with C. And still store into accumulator and add A. Add A. So B multiply C, add A, and still we store into accumulator, and now we divide with T. Now T is D multiply E, D subtracts E multiply F plus G multiply H. So now we divide with C. So it becomes like this and store into accumulator. So now we store into X. So it's gonna be like this. So that's all. Thank you.